Hello friends, welcome back to the next lecture session. Here we will continue from the previous lecture session where we were talking about the basic operating elements of public transportation. And the previous lecture we looked at several operating elements such as capacity, utilization, stops, lines. Whereas in this session we will continue and move forward and look at three distinct topics. One is what is online travel time, what is passenger travel time, what are the different types of speeds involved in public transportation, and then we will end with classifying different types of public transportation and give you an idea of how they are classified. So, we are always worried about travel times on public transportation, right. We always want it to be fast, we always want it to be on time, on schedule. Otherwise, what happens is we shy away from public transportation and we say that we will use our own private mode of transportation because that is more reliable. So, these travel times have various elements associated with it. Let us look at it one by one. So, the first travel time involved in public transportation is what is called a running time. So, running time is the time interval between a transit units starting from one station and stopping at the next one. Okay. So, simple enough, it is the time interval between a transit units starting from one station and stopping at the next one. Next, when we look at station standing time, or which is also popularly called as the dwell time, that is the duration of a transit unit standing at a station for boarding or alighting of passengers. So, as we move forward in the lectures of public transportation system, you will see that dwell time is a very major factor in determining what is your overall travel time on a public transportation line. So, just to clarify, station standing time or dwell time is the time, is the duration when the transit units are standing at a station for boarding or alighting of passengers. Next, when we talk about station to station travel time, it is the time interval between a TU's departure from two adjacent stations. So, it is the summation of the running time and the station standing time. So, station to station travel time not only includes the running time, but also the station standing time. So, it is the time interval between the TU's departure from two adjacent stations. So, these are two adjacent stations that we are using to calculate this station to station travel time. So, very simplistically, it is just the summation of the running time and the dwell time which gives you the station to station travel time. So, I represents the spacing of the stations along that line. So, depending on the spacing, these travel times differ. Okay. The spacings are not always uniform throughout a line. They may differ from an area which is densely populated, that may have very close stations spaced to each other, whereas an area which has less population density, the station spacings may be different. So, depending upon the spacings of the station, the running time or the travel time differs. Next is what is called the operating time or the travel time. It is the scheduled time interval between the departure of a TU from one terminal and its arrival at the other terminal on the line. So, now you remember what is a terminal station, right. So, terminal stations are the two end stations. So, when we talk about an operating time, we are looking at the time that is when the vehicle or a TU leaves one terminal and when it arrives at the other terminal on the same line. So, so far we have looked at travel times between adjacent stations, and now if you sum up all those travel times along the adjacent stations for each adjacent station, then you would arrive at what is called the operating time or the travel time. So, that is what the equation also shows. Now, there is another element called terminal time itself. So, terminal time is the time a TU spends at a line terminal. So, once a vehicle gets to the terminal point, there are various activities that happens at that point. So, it is not that a vehicle arrives at its end terminal and it immediately reverts back and starts its reverse journey along the line. Usually, the terminal time includes the vehicle turning time or how much time it takes to turn around for the next trip, change in drivers. So, maybe the scheduled line has a different driver, change in resting of the crew. So, there is some time in public transportation. We have to remember that labor laws apply. So, we have to give resting time to all the crew, the drivers and the conductors on the line. So, there is some resting time involved, adjustment in schedule. So, maybe the vehicle has arrived ahead of schedule or is late on schedule. So, how do you adjust all those schedules for the next run to begin? That is all taken in the terminal time and recovery for delays as well. So, terminal time is the time that a transit unit spends at the line terminal, at the two terminals at the end. The next terminology to remember is what is called a deadhead time. Now, that is the proportion of the TU travel time during which the TU is not in passenger service. So, deadhead meaning it is either headed from its terminal to its depot or back, or sometimes when it is also going, if it is suddenly breaks down on the road and it has to be taken to a maintenance shop. So, that time which is it is not serving any passengers is called the deadhead time. Since it is not serving the passengers, it is usually unproductive, and hence all transit operators want to minimize the deadhead time. Then is the platform time. Now, this is the total time a TU is in operation, including the deadhead time. So, when somebody says the platform time of a TU is this, we have to remember that the platform time includes the deadhead time along with the operational time. So, the operational time when it is actually functioning and serving the passengers plus the deadhead times. So, the deadhead times may be there are each on each side of the two terminals. So, there may be two deadhead times. So, if there are k number of round trips made by a TU on the line, so k times t plus these two deadhead times add up to what is called the platform time. Now, those were all the travel times when we looked at it from the point of view of the operators. Now, if you look at the travel times from the point of view of the passengers, we see that the passenger travel time on a transit line has 4 to 5 different subclassifications. So, first element in a passenger travel time is the time that a passenger takes to reach the station from his or her origin, right. So, a public transportation line does not come to your home or your college or your restaurant or your hotel. You have to reach to that point. So, there is some amount of time that is involved in reaching to a bus stop or a metro station. So, that is the first element in a passenger's travel time, to a public transportation line. The second is the wait at the station or the stop. You have to wait, maybe the bus or the metro does not arrive immediately. The third is the actual travel time on the transit line. So, we usually always think that this actual travel time on the line is the total passenger travel time. That may be a significant portion of the total passenger travel time, and that is what we want it to be, but many a times accessing and egressing from the transit stations and waiting at the transit stops also take up a lot of time. And sometimes the next element may not always be present, but sometimes if you are transferring between two stations or two transit lines, then there is some time that is involved in this transfer. So, that is also has to be added or taken into account when we are calculating passenger travel times. And the last element is, once you get off of the transit line, you have to then again go to your final destination. You have to access your final destination. So, that may be very close to the stop, that may be a little bit farther away, but it may take some time. So, that time also has to be included. So, you see, when we talk about passenger travel time, it is not only the travel time on the transit line, but there are other elements associated with it as well. So, now let us break it down and look at each of those elements. Now, access, the first element is the access time. The access time is the time which an individual passenger requires for approach to a transit stop or departure from a stop to a destination. So, at both ends of the trip, where the passenger is accessing the station from his or her origin and is then accessing his final destination from the stop where he or she disembarks from the transit line. So, both of those are called access times. So, you have to take both of those into consideration. All right. The next is what is called the waiting time. Now, this is the time between passenger arrival at a stop and the time of the TU departing that stop. So, usually we want to minimize these waiting times, and passengers also look at minimizing these waiting times. So, when we looked at the headways in the previous class, we said that if the headways are greater than 6 minutes, we usually want to have clock headways which are divisible by 60. So, what usually, if the passenger knows that the next bus arrives 10 minutes past the hour, so he or she calculates the time it needs for him or her to travel from the origin to the bus stop, and then optimizes that so that he or she has to wait there for the least amount of time. So, this waiting time is always we subconsciously try to optimize it so that we do not have to wait at the bus stop for a long period of time. If the headways, if the transit headways are very small, then we do not usually have to calculate that, because you know that you will be waiting there for 1 or 2 minutes only, because the frequency of service is very good. Now, the online travel time is easy to understand, is the duration of passenger travel in a TU for a given trip. So, it is actually the time when the passenger is on board a transit line. Transfer time is the time used for transferring between different lines or modes. So, what happens is, now you have different types of modes or different types of public transportation modes that you can take to complete your trip, right. So, you may be traveling from point A to point B, but point A to point C first you go using say for example bus, and then point C to point B, the larger leg, you go on a metro. So, now you are dependent on two different schedules or two different headways. So, there is a bus schedule and then there is a metro schedule. So, when you are transferring from a bus schedule to a metro schedule, you see there is this transfer time involved. Now, if your bus and schedules and your metro schedules were aligned with each other, were integrated with each other, then this transfer time could have been minimized or would be minimized. But in many most of the cities around the world, such coordinated systems are very few. So, if the bus schedule, if there is a delay in the bus, suddenly you would see that your transfer time is increasing, because now you have missed the metro and you have to wait a little bit longer to get to the metro. And then there is also the actual transfer time. So, it is not only the transfer wait time, but now maybe the bus stop is 5-minute walk to the metro station. So, you have to actually walk from the bus station to the metro station, then wait for the metro. So, all of that includes the transfer time between two modes or two different lines of public transportation. And then comes the final origin destination travel time, that is the total passengers travel time from point of origin to point of destination. So, that is the summation of the access time, wait time, the online travel time, and if there is any transfer time involved. So, all of those summations is what is called as the origin destination travel time. Now that we have looked at the travel times, similar phenomenon is to look is the travel speeds or vehicle speeds or travel speeds. These travel speeds have 4 different types of speeds that we will be looking at. The first one is called vehicle speed. So, maximum technical vehicle speed is the highest speed that a vehicle is capable of achieving on a straight horizontal way under normal conditions. So, now every vehicle has their limitations. So, every vehicle on a transit line can only achieve a certain maximum technical speed, right, and also depending upon. So, it is you may notice that it is said on a straight horizontal way. So, this is the, if there are lots of curves on the road or on the transit line, the maximum technical speed may not be achieved, and under normal conditions, meaning it is a bright sunny day, there is no rain or there is no fog or such and such things. So, that is called what is called the maximum technical speed, which is the vehicle speed. Now, there are different kinds of speeds that are associated with the actual alignment of that transit line. So, line design speed is the first. The line design speed is the maximum speed transit vehicles can achieve on a given section of line with adequate comfort and safety. Okay. So, on a section of, so there may be different sections in the same line. On a section, the line design speed depends upon the safety and comfort of the passengers traveling. So, usually we do not want to achieve the maximum speed if comfort and safety is compromised. So, the line design speed and the maximum technical speed have some relationship with it. We want to keep the alignment, we want to keep the line design speed as per the alignment, as per the different sections in a transit line. Then there is a legal speed, is the maximum speed transit vehicles can legally operate at a given section of a line. This may be less than or equal to design speed. Just like on the roads, we have speed limit signs which are legally enforced or can be legally enforced. Similarly, there is some legal speed on which the transit vehicles can operate. Next is the programmed speed. Now, this is the speed that can be actually achieved. Okay. So, the programmed speed is the speed transit vehicles can operate meeting standards of safety, comfort, economy and performance. So, they are programmed to travel on that speed. So, you would see that sometimes buses are traveling on the road, but the roads are empty, and you would think that why aren't the buses speeding up? This empty road, you can go fast, but they are programmed to go at a certain speed because they have to maintain their schedule at each stops, because people at the next stop know that the bus comes at this point at this time. So, you cannot go fast and bypass that scheduled time. So, there is always a programmed speed associated with it. So, that is what essentially a programmed speed means. The next category of speeds that we have to be aware of are the vehicle online speeds. Now, when the vehicle is running or when you are on a vehicle on a transit line, what are the different speeds that can be defined? First one is the running speed. So, when we say running speed, it is the average speed TUs can achieve from leaving one station to arriving at the next one. Okay. So, similarly, now you will find lot of similarities between the travel times that we have looked in the earlier definitions. So, this is the average speed TUs can achieve from leaving one station to arriving at the next one. There may be different types of vehicles running on the same line. What is the average speed or the average speed that all of these TUs have achieved? Okay. The next is the station to station speed. Now, this is the average speed between moments a TU leaves two adjacent stations, right. So, what would be included in this? It will the included would be the time taken to stop at the station. So, at the when the station when the vehicle stops, the speed is usually 0. So, this is will be taken into consideration at the in the station to station speed. Now, operating or travel speed, this is the speed that is offered to the public. So, when we say that a transit line operates at this operating speed or travel speed, this is what we mean is the average speed of TU travel along the transit line. The average speed, sometimes in some times of the day it can be higher, in some times of the day it can be lower based on congestion on the street. If it is a metro kind of transit, operating speeds are pretty constant throughout the day depending upon headways of course, but it usually pretty similar throughout the days. So, that is what is the speed that is given to the public. So, the public then can calculate to travel 10 kilometers, this is the average speed that the transit vehicle is operating. So, I can reach my destination or the destination stop or station by this time. So, this is the element that is taken into consideration. The next thing is cycle speed, and this is the average speed of a TU for a complete round trip on one line. So, once the transit or unit completes a round trip, so back and forth. So, what is the average speed during this entire run is known as the cycle speed. And lastly, platform speed is the average speed the TU average speed of the TU from the time they leave the depot until they return back. So, remember there was a platform travel time as well. So, this is similarly a platform speed where the depot travel times or the depot the speeds from with which they travel from the depot to the transit line and back are calculated. So, it is not only the operating travel speed, but also the speed with which they on which they operate when they are going back and forth from the depot as well. Lastly, the other type of speed that has to be considered is the passenger speed. Now, just as passenger travel time, there are different aspects of passenger speeds as well. So, access speed. Now, access speed is the average speed of a passenger travel to and from transit stops or stations. So, just as there is travel time involved to access a transit stop from say your home or your college to the transit station, similarly there is speed involved. So, now you can either walk to the transport stop or station, or you can come on a bicycle, or you can take your own vehicle and park there. So, all this will have different types of speeds involved. So, these speeds play a very important role when we are calculating again the passenger travel times. So, a passenger may be in a hurry. So, he or she may take his motor vehicle, two-wheeler or car to the public transportation stop or station and park it there and then take the metro or the bus. But if parking is not available, then he or she may have to either walk or take some other intermediate public transportation mode such as rickshaws or cycle rickshaws or whatever they may be, and then access the public transportation line. So, that speed is called the access speed. Then the origin destination speed is the average speed of the passenger travel along his or her path from origin to destination. Now, this is the total origin to destination speed, which will also have access speed and speed on the transit line, right. We have already looked at speed on the transit line. So, if you add access speed on both ends of the trip, now that will give you the origin destination speed, the average speed of passenger travel along his or her path from origin to destination. So, those were all the different types of speeds and travel times that we were able to show you, and that is something that you have to remember as we move forward and try to solve some problems. Finally, let us look at how differently we can classify all these types of surface public transportation systems. We have already looked at the right of way elements and how they can be classified as C, B or A. They can also be classified as different types of vehicle guidance, like they can be steered vehicles like buses, or they can be guided vehicles which are on rails, and sometimes on rubber tired transport as well, but mostly rail transport, metro rail or light rail or public transportation lane or regional rail. All of these are usually guided systems, guided public transportation systems. Next, if we move on, they can be also classified based on propulsion, either they are IC engine vehicles, or they are electric vehicles, or they are induction motor. So, there are different types of technology that these transit vehicles may be using, and they can be classified separately as well. The main basis for classification is that the operating costs and the headways and all can be calculated based on all these different elements of classification. Transit unit driving and control, it may be driver driven. You already know that there are a lot of light rails or metro rails that are automatic train operation. So, they do not have any driver, and the vehicles run automatically on the rails. And now, of course, there are autonomous vehicles that are also coming up. And then the other type of categorization that can be done is based on service. So, there may be many overlapping routes. There may be, we will look at how different types of public transportation networks are set up. We have only looked at couple of maps where you saw that there were a lot of overlapping routes, there were a lot of interconnecting routes, but they all have their basic advantages and disadvantages. And based on the character of the city, these all types of services are developed. So, public transportation system can also be categorized based on what type of service they provide, the type of network and operations that is available. So, now that we come to the end of our basic operating public transportation module, we have covered in this lecture all the other elements such as the running times, the different types of times involved, such as station standing time, station to station time. We also looked at access time, waiting time, and then we looked at different types of classifications that are based on right of way, vehicle guidance, propulsion or driving control. So, I hope you have now got your basic foundations of public transportation, and from the next class onwards we look forward to giving you some examples, solving some examples based on all these terminologies, so that you understand how a basic transportation system works. Thank you.